section 1.3, zero in division. That's what we're talking about today. So this is stuff that we've talked about lots in Pre-Cal 30. The first thing we're looking at is when we have a 0 in the numerator. Okay, so when we have zeros in the numerator, that's when we're talking about our x-intercepts, our zeros, our roots. What's the other word for them? Roots, zeros, x-intercepts. Okay, so when we're talking about the numerator can have a 0 in it, and this part here, this is the numerator. When we factor it out, we find out the factors are 2 and minus 2. So those are the x-intercepts of the equation. Okay? Let me cruise. Oh, did it change? Oh, yeah. Okay, so then we also talk about when there's a 0 in the denominator. Okay, so when there's a 0 in the denominator, that's when your equation is undefined there. Right? Zeros in the denominator are bad. You don't want to have them, right? And so in this equation, if it says y is equal to 4 over x minus 2, the denominator, what would make the denominator 0 in this situation would be if x was equal to 2. So that means that we have a vertical asymptote at that spot. Okay, so zeros in the denominator mean that you're going to end up with a vertical asymptote because you cannot have 2 as part of your equation in there. It'll make your equation 4 over 0, which is not allowed. It's undefined. Okay? So then the other part is, so we've talked about zeros in the numerator, which make x-intercepts, zeros in the denominator that make things undefined. And then we talk about if we get a 0 and a 0 in the numerator and in the denominator. Okay, so if they show up in the numerator and in the denominator, then that's called the indeterminate. Okay, and we just actually finished talking about those in Pre-Cal 30 because those are when we had holes. Does anybody remember when we talked about holes instead of vertical asymptotes? Okay, so that is what an indeterminate is. Okay, so if we were to factor this equation here, it's factored out in the bottom corner of your sheet there. You have x minus 2, x plus 1, and then you have an x minus 2 in the bottom. Okay, so the x minus 2's can cross off, and you're left with just x plus 1. Okay, so this would be considered a hole in your graph. It's not a vertical asymptote anymore because it makes your numerator and your denominator 0 in this area. 0 here and 0 here, right? Okay, so go to my next slide. When, is this the same question? Oh yeah. Okay, so when we're there, we say when we get to the graph, this is at x equals 0, we have a hole in the graph. Okay, so that's what I was saying, because these can cross off, that creates the whole situation. So our x is 2, and if we want to find the point of the hole, yeah? Yeah. Yep. So we plug 2 into the equation. And since we're only left with x plus 1, 2 goes in where the x is, and you have 2 plus 1 equals 3. So our point is 2, 3. That's where our hole is in our graph, or our point of discontinuity. Okay, so we had just finished talking about this in Pre-Cal 30. And if we were to show what this actually looked like. So remember, a vertical asymptote is a dotted line where our picture doesn't cross. A hole is actually just a hole in a line or a graph that shows up that we don't include. Okay, so if our equation is, what we're left with is x plus 1, we remember how to graph these because our 1 is our y-intercept, and the values in front of x are our slope. So since we have a 1 and a 1 in front of our x, we have a rise of 1 and a run of 1. So we can draw our picture by starting at our y-intercept, which is 1, and then our slope is a rise of 1 and a run of 1. So we can rise 1 and run 1. And if I used a nice straight edge, which I didn't, we have our line that forms. Okay, now it's important that we put our hole in, because we cannot have our picture jump spots at 2, 3, right? So if we go 2 over and 1, 2, 3 up, it's a little bit off in my picture, but this is what a hole would look like on this graph. Whoop. Let me hit it here. Okay, that's close enough. So it's like a line with a gap that's missing out of it. Okay, so this is talking about holes versus vertical asymptotes. Okay, because sometimes we get into a situation where we can cross something off and we think, okay, that's an indeterminate. That's going to make a hole in our picture, where it actually makes a vertical asymptote. Okay, and the question is why and when does that apply? Okay, so just to make this seem like an easier form, we'll look at the example, and you might want to see it on page 21 in your book. It's example 3. Okay, and it has the equation f of x is equal to x squared minus 2x all over x squared minus 4x plus 4. Okay, and it says explain the shape of the graph at x equals 2. And I'll just draw like a little rough graph here of what they have in the textbook. They have a vertical asymptote at 2, and then the graph looks like this. Okay, so it's not crossing at 2 and there's a vertical asymptote there. Okay, so if we were to factor this f of x equation, we could take x out of the top, and we take out a common x, and we'd be left with x minus 2 in the brackets. And on the bottom, we can factor by going what multiplies to the 4 on the outside adds to the minus 4 in the middle. Okay, so it's going to be x minus 2 and x minus 2. Okay, because minus 2 and minus 2 add up to minus 4. Minus 2 and minus 2 multiply to positive 4. Okay, so then if you notice, we got an x minus 2 and an x minus 2. So we would cross those off, right? And that would be a hole or an indeterminate. Okay, but in this situation, we're still left with an x minus 2, which is where the vertical asymptote comes in. Okay, so that is all this whole explanation is talking about. So it's saying that if your P is greater than or equal to your Q, meaning the power of P and Q in this and this, then you will have a hole. Okay, so if you have a bigger power in the top or an equal power to the bottom, then you'll have a hole. But if you have the greater power in the bottom, like in this situation, then you're going to end up with a vertical asymptote. So this situation, even though we cross these off, you're going to have the vertical asymptote at x equals 2. Okay, so x cannot equal 2 in that equation. Okay, so if we look at the example on our sheet, f of x equals x cubed minus 9x over x cubed minus 2x squared minus 3x. Okay, so the question that we're asking is, it says, what is the 0, where is it undefined, and what is the indeterminate? Okay, so we're trying to find 3 things in this. So remember, the 0 is when your x equals 0 in the top, the undefined is what makes your x 0 in the bottom, and your indeterminate is what you can cross off. Okay, so first thing we want to do is factor this. So I can take a common x out of the top, and then I would be left with x squared minus 9. Can I go farther with that one? yeah, it's a difference of squares. So I'm going to factor him a little bit more. So I still have the x outside, but this is the difference of squares. So this is x and 3 and 3. So I'm going to write them as x minus 3 and x plus 3. Okay, in the bottom I can take a common x out. And I'm left with x squared minus 2x minus 3, which I can factor because that's a trinomial. So I'm going to look for what multiplies to minus 3 but adds to minus 2. And that is minus 3 and 1. And a positive 1. Okay, so now that we have it all broken down, this is where we figure out what we can cross off and what we're left with. Okay, so we can cross an x minus 3 off in the top and in the bottom. Okay, so our first question was, what makes our top 0? What are our zeros for our top? Oh, sorry, I should have crossed the x's off also. Okay, now let's focus on what makes the top 0. Minus 3 does. Perfect. How about what makes our bottom undefined? Negative 1 is left. And what is our indeterminate? What is the things that we crossed off? 3 and 0. Okay. This next question says, is there a whole, a vertical line, or neither at x equals minus 3 in these situations? Okay, so this, we just have a normal equation, 2x plus 6. Does this create an asymptote or a whole or anything like that? No, nothing. Okay, so you would say none in this situation. Okay, what about this f of x equation? We should probably factor before we look at it, so we can take a 2 out of the top. And we're left with x plus 3 in the brackets. And these could cross off. So would we be left with a vertical asymptote or a whole or neither? A whole, right. And it's going to be at negative 3. And if we wanted to put the whole point in there, it would be negative 3 and 0. Looking at the next one, x minus 3 and x plus 3 on the top, or x minus 3 on the top, x plus 3 on the bottom, and we can't cross anything off. We can't really factor this right now, so are we going to be left with a vertical asymptote or a whole? Okay, we'd have a vertical asymptote, and it would be at x equals minus 3, right?